Hello children, how are you all? Hope so you are doing good. Welcome to a session on rectilinear figures. The concept belongs to class 9 ICSE, where we are going to solve the exercises on the chapter rectilinear figures from Concise Mathematics, that is Selina Publication. Keep in mind children, it's a must to watch video. Don't miss to watch the video till the end, and also refer your friends, ask them to watch the videos, like the videos and share the videos. Before we proceed with the concept, I request you all guys to subscribe the channel, that is Ignite Math ARP, then proceed watching the video. It's a really fun children. Please be with me till the end. Yes, let's not delay. Let's start with a concept, that is a rectilinear figure, chapter number 14. Yes, children, you might have heard about a term rectilinear. Please, can you tell me where have you heard about the term? Don't say that you have just heard it from me itself. No. Okay. Rectilinear. Have you heard about rectilinear propagation of light, children? Can you tell me? Rectilinear propagation of light. Where the concept comes? Okay, so we say that light always travels in a straight line, correct children? And also you might have heard about the rectilinear motion. Have you heard about it? The motion or the path traveled by the body which moves in a straight line. Okay, that is called as rectilinear motion. Here in mathematics, the plane closed figures, keep in mind the plane closed figures bounded by the straight line segments, okay, we are going to call them as rectilinear figures. Okay, so keep in mind rectilinear figures are also called as polygons. Poly means what? Many. The plane closed figure closed by many straight line segments are called as polygons or rectilinear figures. See, you have learned the properties and types of triangles, but you don't know it is called as a polygon. You have studied the properties and types of the quadrilaterals, but you don't know it is called as a rectilinear figure. You might have heard about a pentagon, okay, a five-sided polygon. You don't know it is called as a rectilinear figure. Always keep in mind children, whenever you are going to name a rectilinear figure, we are going to name them either in the clockwise direction or in the anti-clockwise direction. This is a very basic thing what you need to remember. Clear? Say for example, A, B, C, D. This is the right way of naming a rectilinear figure. Okay, but most oftenly what children do, you do that A, B, C, D. This is a very wrong way of okay, naming a polygon. Okay, either you go in the clockwise direction or you come in the anti-clockwise direction. See, I'm coming in a anti-clockwise direction here. A, B, C, D. Doesn't matter where actually you are going to start naming them, but name them in the direction which I mentioned, either in the clockwise or in the anti-clockwise. And what are the different types of rectilinear figures? What are the different types of polygons? How actually we are going to call them? So we are going to name the polygons depending upon the number of sides they have. Clear children? Here I have brought you some of the pics and the names of the polygons. Observe over here. A three-sided polygon is called as a triangle, and a four-sided polygon is called as a quadrilateral or quadrangle, and the five-sided polygon is called as pentagon, six-sided polygon is called as hexagon, septagon or heptagon. Okay, seven-sided polygon, and eight-sided, you might have heard about the term octagon. Okay, right, where have you heard octopus, eight-legged, okay, organism, octopus. So similarly here, octagon we are going to call a eight-sided polygon as, and the nine-sided polygon is a nanogon, and the 10-sided is a decagon, undecagon and a dodecagon. So similarly we can keep on naming the polygons depending upon the number of sides they have. Clear children? Okay, pentadecagon, tetradecagon, hexadecagon, like that. Clear children? Right. So you must keep in mind that whenever a polygon is drawn, okay, so number of sides it has, look at this, AB, BC and CA. Here I can say the sides are AB, so BC and CA are the sides, and the angle which are interior to the polygon, the angles which are inside the polygon, they are called as interior angles. What they are called as? Interior angles. Here angle A, angle B and angle C are interior angles. When the side of the polygon is extended, produced either in the clockwise direction or in the anti-clockwise direction. See here I am extending the side of the polygon like this. Look at this. Okay, so whenever I'm extending the side of the polygon like this, there is one more angle formed by this side, but it lies outside the polygon. That's why we are going to call it as a exterior angle. Clear, children? Okay, exterior angle. Here this is exterior angle, this is exterior angle. Always keep in mind, children, in a polygon, number of sides is equal to number of interior angles, and also the same equal to number of exterior angles. Keep in mind, children. Okay, so similarly over here, if you take a quadrilateral, look at this, I'm taking a random quadrilateral over here, right? So it's a four-sided polygon. Okay, so I'm extending the sides of the quadrilateral in the clockwise direction. Look at this angle so formed, which is outside the polygon, children. So here this angle, see, this is the exterior angle, this is the exterior angle, this is the exterior angle, and this is the exterior angle. Clear, children? So number of sides is equal to number of interior angles is equal to number of exterior angles in a polygon. You must know this always. Is that clear, children? So now let us proceed with the what will be the sum of interior angles of a polygon. You may ask, see here, sir, we have learnt that sum of all the angles of a triangle is equal to 180 degree. So sum of all the angles of a quadrilateral, sum of all the interior angles of a quadrilateral is 360 degree. So is it different for different polygons? Yes, obviously yes. Okay, children. So sum of interior angles of the polygon depends upon the number of sides the polygon has. Clear, children? Right. So how can we find out the sum of interior angles? So what is the sum of interior angles of the octagon? What is the sum of interior angles of a dodecagon? Okay, it is quite okay difficult for us to keep on finding the sum of them by measuring them with the protractor. Clear, children? So we have to have a formula to find out the sum of interior angles of the polygon. Clear? So what is the formula? So I don't want you guys to just remember the formula, but I want you to understand how actually we arrive at the formula. Clear? So please pay attention and stay with me. Look at this. I'm drawing a triangle. I'm drawing a triangle. So here the number of sides is 3. Clear? The sum of interior angles is 180 degree. Correct, children? You know all the interior angles add up to 180 degree. Clear? Number of sides is 3. Sum of interior angles is also 3. How many triangles are there? There is only one triangle. So sum of interior angle is 180 degree. Suppose if I take a quadrilateral. Okay, if I take a quadrilateral, how many sides the quadrilateral has? It has 4 sides. If I draw a diagonal, see the quadrilateral is divided into 2 triangles. So 180 over here and 180 over here. So I can say there are 2 triangles in the quadrilateral. So sum is going to be 2 into 180, that is equal to 360 degree. So similarly, if I am talking about a pentagon, you have to draw the diagonals such that no 2 diagonals intersect each other, in the sense you are dividing the polygon into triangles triangles. Look at this, children. So here and here I will draw. So this is 180 degree, this is 180 degree, and this is 180 degree. So number of sides is 5. 3 triangles are formed. So the sum is 3 into 180 degree, that is 540 degree. Similarly, if you take a hexagon, look at this, children. We can derive a formula. We can generalize the sum of interior angles. Okay, focus. No, I will draw one diagonal over here, one diagonal over here, and one diagonal over here. There is one triangle formed over here. This is 180 degree, this is 180 degree, this is 180 degree, and also this is 180 degree. So for a six-sided polygon, the number of triangles formed is 4, and the sum of interior angles is 4 into 180 degree. So that is nothing but 720 degree. See, children, whenever 3 sides are there, one triangle is formed. 2 sides are there, 4 sides are there, 2 triangles are formed. 5 sides are there, 3 triangles are formed. Okay, 6 sides are there, 4 triangles are formed. Can I say the number of triangles formed over here is 3 minus 2. Number of triangles formed over here is 4 minus 2. Number of triangles formed over here is 5 minus 3. Number of triangles formed over here is 6 minus 2. Here 5 minus 2. Clear, children? So whatever is the number of sides the polygon has, minus 2 if I do, I will get the number of triangles formed. Okay, for a n-sided polygon. Okay, for a n-sided polygon, so what is the number of triangles formed? Can you tell me? Number of triangles? Yes, same. Good. What is coming in your mind is right. So that is nothing but n minus 2 triangles are formed. So whatever is the number of triangles formed, that into 180 is the sum of interior angles. So n minus 2 is nothing but the number of triangles formed. This into 180 will give you sum of interior angles of any sided polygon. Clear, children? So I can say that sum of interior angles of n-sided polygon or a rectilinear figure is given by the formula n minus 2 into 180, which can also be written as, look at the board, children, look at the screen very carefully, n minus 2, this 180 I will write it as a 2 into 90. Clear? So if I multiply n minus 2 into 2, then I can write this one as 2n minus 4 into 90. Either you can use this formula to find out the sum of interior angles, or you can use this formula also to find out the sum of interior angles. Then one question arises in your mind. Yes, I can sense it. Sir, you told about sum of interior angles. So how to calculate the sum of exterior angles then? Clear, children? Very clear it is. Whatever is the number of sides, okay, whatever is the value of n, okay, sum of exterior angles of n-sided polygon, okay, n-sided polygon is always 360 degree. So what I mean to say, the sum of interior angles depend upon the number of sides the polygon has. Okay, but sum of exterior angle does not depend upon the number of sides the polygon has. It is always 360 degree. Keep in mind. Okay, sum of exterior angles of triangle is also 360 degree. Hexagon is also 360 degree. Decagon is also 360 degree. You name the polygon, sum of exterior angle of that polygon is always 360 degree. Keep that in mind. Clear, children? I hope so it is clear to you. So remember this formula. Either you remember this formula to find out the sum of interior angles, or you remember this formula to find out the sum of interior angles. Yes. Now the next concept is, see, I am drawing a diagonal. You must understand what do you mean by diagonal. Can you define what is diagonal, children? Diagonal of a polygon is nothing but the line segments which connects the non-consecutive vertices. right? What are vertices? A is a vertex, B is a vertex, C is a vertex, D is a vertex, E is a vertex, and F is a vertex. Clear? So if I'm drawing a line segment connecting non-consecutive, what do you mean by consecutive? A is consecutive to B and F is also consecutive to A. So non-consecutive in the sense A connected to C, A connected to D, A connected to E. In these cases, they are called as the diagonal. Similarly, I can connect to B, F, B, E, B, D like that. Okay, it is very difficult for me to keep on connecting all the non-consecutive vertices and then say what is the number of diagonals. Okay, so for this also I am going to derive a formula to find out the sum of number of diagonals in the polygon. Let us derive. It's fun, children, it's fun. Okay, I don't want you to learn the formulas are not god gift, children, they are man-made. You need to understand how the formulas are derived, don't simply learn them. Clear, children? Let us derive how actually the number of diagonals of the polygon to be calculated. Now pay attention, children, pay attention. For the triangle, all the vertices are consecutive. Okay, number of sides is 3. Diagonals, I don't get any of the vertices non-consecutive over here, so I can say that the number of diagonals over here is 0. Clear? Right. So now I will say a quadrilateral, right? So now A, B, C, D is nothing but a quadrilateral. How many diagonals I am getting here? See, AC is one diagonal and BD is another diagonal. So if number of sides is 4, the diagonals is 2. If I have a pentagon, pay attention, children, pay attention. Okay, A, B, C, D, E. Now I will draw a diagonal over here. Here. Clear, children? How many diagonals I'm getting? Look at the screen very carefully. AD is one diagonal, AC is one diagonal, 2, 3, 4. Okay, then I'm getting DB. Okay, AC, all of them are diagonal, children. So if you observe carefully, the number of diagonals formed, see here, 3 numbers are there, number of sides is there, 0 diagonal is there. Clear? Okay, if 4 sides are there, then we have got 2 diagonals. Find out how many diagonals are there in the pentagon. A D is one diagonal, AC is another diagonal, EB is one diagonal, EC is another diagonal, then DA and AD are same, DB is another diagonal. Clear? Then EC and CA are same, AC is same, DB we have written, and EC 1, 2, 3, 4, 5 diagonals we have got it. Clear? 5 diagonals I have got it. So now you need to observe, children, the number of diagonals formed in a polygon is given by the formula n, that is number of sides, n minus 3 divided by 2. Think about it, children. Think about this is a number of diagonals. How it is actually we arrived at this formula? See, I will show you for the triangle. Okay, if n is equal to 3, then the number of diagonals is 3 into 3 minus 3 by 2. So that is 3 into 0 by 2. Any number multiplied by 0 is 0. 0 divided by 2 is 0. See, number of diagonals is 0. For a quadrilateral, n is equal to 4 we have. So number of diagonals is 4 into 4 minus 3 by 2. That is nothing but 4 into 1 by 2. 2 ones are 2 twos are. See, number of diagonals we have got it as 2. So if n is equal to 5, okay, number of diagonals is equal to 5 into 5 minus 3 divided by 2. So that is 5 into 2 by 2. So that is equal to 5. See here we have got it as 5. So I can say that the number of diagonals in a polygon is given by the formula n into n minus 3 by 2, where n is a number of sides in a polygon. Clear, children? I hope so it is clear to everybody. Yes or no? Yes. Okay. Now let us go to the one more very important concept, that is concave and convex polygons. Concave and convex polygons. What are concave polygon and what are convex polygon? See here, when I draw one polygon over here, children, right, try to differentiate over here. I'm drawing one more polygon over here. See, what is the number of sides over here? Number of sides is 4. What is the number of sides over here? Number of sides is again 4. This is called as a quadrilateral. This is also called as a quadrilateral. But what is the difference between them? See, when I'm talking about the interior angle of this quadrilateral, all of them are less than 180 degree. Okay, but when I'm talking about the second quadrilateral, one of the angle is more than 180 degree. So any angle which is more than 180 degree, less than 360 degree, we call them as a, what we call them as reflex angle. Yes or no, children? Okay, so the reflex angle, right? So a polygon, you keep in mind, children, a polygon having all its interior angles less than 180 degree is called as a convex polygon. Is called as a convex polygon, whereas a polygon having at least, okay, at least one angle as a reflex angle, then we call that polygon as a concave polygon. We call it as concave polygon. Clear, children? Is it clear? If I'm simply referring as a polygon, if I'm just talking as a polygon, that means what? I'm addressing a convex polygon. I'm addressing a convex polygon. If I want to speak about a concave polygon, I should mention it as concave polygon. If I'm simply telling a polygon, that means what? It is a convex polygon. Clear, children? I hope so it is clear. So clear? Yes. Let's move to the next concept now. Yes, children, the next concept is regular polygon. So we are going to study about when the polygon is called as a regular polygon. Okay, a polygon is called as a regular polygon only if the polygon satisfy these conditions. Okay, a polygon having all sides equal to each other and all interior angles equal to each other and all exterior angles equal to each other. So when a polygon satisfies all these three conditions, okay, it should have all equal sides, then each interior angles are equal to each other and each exterior angles are equal to each other, then a polygon is called as a regular polygon. Clear, children? So now here I'm just drawing a triangle where all its sides are equal to each other. What you are going to call this triangle as? Can you tell me? It's called as a equilateral triangle. Clear, children? Right. So if I'm asking you what is the sum of each interior angle of a triangle, you would say it is 180 degree. Correct. So now what is the measure of each interior angle over here? Can you tell me, children? Right. So if I ask like that, you will say that sir, over here each interior angle over here is 60 degree. Can you tell me how you got 60 degree? You have divided sum of interior angle divided by number of sides, right? So the same logic here we are going to use to find out the value of each interior angle of a regular polygon. Clear? So I can say that each interior angle of a regular polygon is given by the formula 2n minus 4 into 19 divided by n, because here divided by 3 we have done. Correct, we have divided by number of sides. Sum is divided by number of sides. Okay, then we got 16. So similarly over here 2n minus 4 into 90 is the sum of interior angles that should be divided by the number of sides in the polygon, that will give you each interior angle of a regular polygon. This can also be written as n minus 2 into 180 divided by n. So this can also be the formula to find out each interior angle of a regular polygon. Now can you tell me what is the sum of exterior angle of any polygon? It is 360 degree. So again, so each exterior angle of a regular polygon is sum of all the exterior angles divided by number of sides in the polygon. So that will give you each exterior angle of a regular polygon. If I want to find out the number of sides in a regular polygon, then it is given by 360 degree by each exterior angle. Can I say, children? Tell me why? Because I'll just take this n to the left hand side and each exterior angle to the right hand side. This can also be used to find out the number of sides. Clear, children? Okay, keep in mind n is always a natural number greater than 2. Clear? Whenever I'm talking about number of sides, that is always a natural number greater than 2. Right? Yeah. So now, as the number of sides are increasing in a polygon, triangle, okay, rectangle or quadrilateral if I say, or pentagon if I say. Clear? In case of a regular pentagon, in case of a regular quadrilateral, in case of a regular triangle, as the number of sides are increasing, the each interior angle is also increasing and each exterior angle is decreasing. And also we can say at any vertex of a polygon, whether it is a regular polygon or not, doesn't matter. At any vertex of a polygon, we can say that interior angle plus of exterior angle is equal to 180 degree. They form a linear pair. Clear, children? So this much concept is more than sufficient to solve the first exercise. Now let us see what kind of questions are stored in the first exercise, that is 14a. See, the first main is multiple choice question. Choose the correct answer from the options given. One angle of a 7-sided polygon. So here what is the value of n over, children? N is equal to 7, because they are telling that it is a 7-sided polygon. Sometimes they will give you that in a septagon or heptagon like that. Okay, so you must remember what is a 7-sided polygon also called as. Clear? Is 114. One angle is 114 and the remaining 6 angles are x degree each. Then the magnitude of x is, then the value of each of the equal remaining angles is. Now let me calculate the sum of interior angles first. Sum of interior angles is 2n minus 4 into 90. Clear? So 2 into 7 minus 4 into 90. So that is a 14. 14 minus 4 is 10. 10 into 90, that is equal to 900. This is the sum of all the angles of a seven-sided polygon. See here, they are just telling you polygon. Don't consider it as a regular polygon. Very important, children. If I am simply telling a polygon, that means what it is? It is a irregular convex polygon. It is always understood, children. If I want to mention it as a regular polygon, I should say it is a regular polygon. If I'm simply saying a polygon, it is always irregular convex polygon. Keep in mind, right? So obviously, if there are 7 sides, 7 angles will be there. Out of 7 angles, 1 angle is 114 and remaining 6 angles are equal to each other. When I add all of them, I'm getting the sum as 900. So my task is to find out what is the value of x over here, right? So 6x is equal to 900 minus 114. So I can write 6x is equal to 786. So now I can say what is the value of x? X is equal to 786 divided by 6. Clear, children? So when I divided this by 6, I would get the answer as 131 degree. That is the right answer. So 131 degree is the right option. Clear, children? Right. Now let's move to the next one. If each interior angle of a polygon is 144 degree, the number of sides in it is, okay. So now each interior angle of a polygon, is 114 degree. Clear? Each interior angle is equal to 114 degree. We know that each interior angle plus each exterior angle is equal to 180 degree. Tell me why? If each interior angle is equal to 144 means what? It should be a regular polygon. Okay, because only in the case of regular polygon, each interior angle will be equal to each other. So here I can write 144 degree plus of each exterior angle is equal to 180 degree. So I can say each exterior angle is equal to 180 minus of 144. Okay, so I have brought this 144 to the other side. So that is equal to 36 degree. So I have got each exterior angle is equal to 36 degree. Therefore, number of sides is equal to 360 degree divided by each exterior angle, that is 36. So 10 is the right answer. So answer supposed to be 10. Clear, children? Okay, now let's move to the next one. An exterior angle and an interior angle of a regular polygon are in the ratio 2:7. Right? So they have given you the ratio here. Clear? So exterior angle is to interior angle is equal to 2:7. That is equal to 2x is to 7x. So I can say that each interior angle plus each of exterior angle is equal to 180 degree. So 2x plus 7x is equal to 180 degree. 9x is equal to 180 degree. X is equal to 180 degree divided by 9, that is equal to 20 degree. So now each exterior angle is what, children? Each exterior angle is equal to 2x is equal to 2 into 20, that is equal to 40 degree. So can I find out number of sides? Number of sides is equal to 360 degree divided by each exterior angle. So 0, 0 get cancelled, 9. So answer is supposed to be 9. You're asked to find out the number of sides, that is equal to 9. Let us see the next one, children. the sum of interior angles of a polygon is 4 times the sum of exterior angles. So what is the sum of interior angle, children? It is 2n minus 4 into 90. This is equal to 4 times the sum of exterior angles. Sum of exterior angles is 360 degree. So it is 4 times in the sense into 4. So I can say 2n minus 4 into 90 is equal to 4 into 360 degree divided by 90. So this get cancelled, 1s, 4s. So I would get this one as 16. Clear, children? I have taken this 90 over here. So I will not write this 90 over here because it is being taken this side. Clear? So I'll be left with 2n minus 4 is equal to 16. 2n is equal to this 4 is taken this side becomes 20. So n is equal to 20 divided by 2, that is equal to 10. So I can say the number of sides is equal to 10. Number of sides in the polygon you are supposed to find out. Now let us see the next question, children. The angles of pentagon. You must know what you mean by pentagon. So in the case of pentagon, n is equal to 5. So sum of interior angles is equal to 2n minus 4 into 90. So 2 into 5 minus 4 into 90. So 10 minus 4 is 6 into 90, that is nothing but a 540 degree. So ratio of the angles is given to you. Ratio of angles is equal to 4 is to 8 is to 6 is to 4 is to 5. So I can write this one as 4x is to 8x is to 6x is to 4x is to 5x. So when I add all these angles, I will get it as 540 degree. So means what? 4 plus 8 is 12, 12 plus 6 is 18, 18 plus 4 is 22, 22 plus 4 is 27. So I can write 27x is equal to 540, x is equal to 20 degree. So I can say first angle is equal to 4x, that is 4 into 20 is equal to 80. Second angle, what is second angle, children? It is 8x. So 8 into 20, 160 degree. So third angle. So third angle is 6x. 6 into 20 equal to 120 degree. Then fourth angle. Fourth angle is 4x again. 4 into 20 is equal to 80 degree. Then fifth angle is equal to 5x. 5 into 20 is equal to 100 degree. You can cross check, children. When you add all of them, you are supposed to get the sum as 540 degree. Now let us move to the next question. 3 angles of a 7-sided polygon. Clear? What is n over here? N is equal to 7. First job is what? Sum of interior angle. That itself give you 1 mark, is equal to 2n minus 4 into 90. So 2 into 7 minus 4 into 90. So 14 minus 4, 10. Then 10 into 90 is 900. Okay. Then 7-sided polygon. 3 angles are 132 each. Okay. So 3 angles are 132. If out of 7 angles, 3 angles are 132, remaining angles are 4. Clear? And they are telling that 4 angles are equal to each other. I will take each of the equal angle as x degree. So I can write it as 4x is equal to 900. Here I will write let each of equal angles equal to x degree. So now here I am left with 4x is equal to 900. Clear? So here 132 into 3 is going to be 396. 396 is taken to the other side. Clear? So 4x is equal to 396 to be subtracted from 900. I will get it as 504. Clear? So now x is equal to 504 divided by 4. So when I divide 504 by 4, I will get it as 126. So I can conclude that each of equal angles, how many equal angles? 4 angles are 126 degree. Don't forget to write the conclusion. Clear, children? Now let us move to the next question. AB, BC and CD are the 3 consecutive sides of a regular polygon. So here this is a regular polygon. Keep in mind, children, this is A, B, C, D. Since it is a regular polygon, all sides are equal. Clear? Why I have not joined it? Because I don't know the number of sides. You can't say that, sir, how can you say it's a regular polygon? You have not closed the figure. I don't know the number of sides in the polygon, so I have not closed it. Right. So 3 sides of a regular polygon. If BAC is equal to 15, BAC in the sense this angle. Right. So this angle is equal to 15 degree. Right, then find out each interior angle, each exterior angle and number of sides of the polygon. Clear, children? So now in triangle ABC, I can say AB is equal to BC. Therefore triangle ABC becomes isosceles. Therefore angle BAC is equal to BCA is equal to 15 degree. So they are nothing but base angles. Okay, in isosceles triangle, the angles opposite to equal sides are called as base angles and they are equal to each other. Clear? If you want to know more about isosceles triangle, I have a video on congruency and isosceles triangle. You can go through it. Correct? So now if this is 15 degree, this also becomes 15 degree. Clear, children? Now I can apply the angle sum property. Angle A plus angle B plus angle C is equal to 180 degree. This is by angle sum property. Right. So I can say 15 plus B plus of 15 is equal to 118 degree. So angle B is equal to 180 minus 30, 150 degree. What is angle B, children? Angle B is nothing but the interior angle of a polygon. So I can say that each interior angle of polygon is equal to, this is nothing but a regular polygon, equal to 115 degree. So now second question, each interior angle plus each exterior angle, okay, each exterior angle is equal to 180 degree. Clear, children? So each interior angle is equal to 150 degree. Then exterior angle I'm supposed to find out. So I will get to know that each exterior angle is equal to 180 minus of 130, that is equal to 30 degree. So each exterior angle is equal to 30 degree. Now my task is to find out the number of sides. We know that number of sides is equal to 360 degree divided by each exterior angle. Each exterior angle is 30 degree. So that is equal to 12. Clear, children? 12 is the number of sides. Right? I hope so. You are finding these questions from the first exercise easy. Now my task is to deal with the quadrilaterals. Clear, children? Before that, let me drink a sip of water. Excuse me, children, for that. Yeah. So now what is quadrilateral? Quadrilateral is again a polygon. A polygon with 4 sides is called as a quadrilateral. It is not necessary for you to tell a plain closed figure and all, because when you are talking about polygon, that is understood that a polygon is nothing but plain closed figure. Clear, children? So now I will draw a quadrilateral over here. Look at this. This is a quadrilateral. Quadrilateral is a special type of polygon where sum of interior angle is also 360 degree and sum of exterior angle is also 360 degree. You will get this kind of questions in MCQ. Name the polygon whose sum of interior angles is equal to the sum of exterior angles. Then the polygon is quadrilateral. Clear, children? It has got 4 sides in it. If I name them as A, B, C, D, these are the 4 sides and 4 angles in it. Clear? So now let us deal with what are the types of quadrilateral. What are the types of quadrilateral? First one is parallelogram. Parallelogram. Next one is rectangle. Next one is a square, I can say, and rhombus. Then yes, what's there in your mind? Tell me please. Trapezium. Then I have kite. Clear? These are the different types of quadrilateral. But for your kind information, whenever I am talking about the parallelogram, the square, rectangle and rhombus, they are the types of parallelograms. Clear? Okay, so square, rectangle and rhombus, they are types of parallelogram. Parallelogram is a type of quadrilateral. Quadrilateral is a type of polygon. Clear, children? Okay, now let us study the properties of each of them. Clear? Now let us deal with the properties of a parallelogram. Alright, so properties of a parallelogram. Right, so now whenever I am talking about a parallelogram looks like this. Pay attention, children. Parallelogram looks like this. So A, B, C, D is a parallelogram. So very first property is what? Both the pairs of opposite sides are equal and parallel. Okay, right, in the sense here I can say AB is equal to DC, AB is parallel to DC. Also BC is equal to AD and BC is parallel to AD. You need to understand, children. If you remember the property, that is not sufficient. You need to understand, apply to these properties to solve the problems. That is the first property. And the second property is what? Both the pair of opposite angles are equal to each other. Okay, so equal to each other in the sense angle A is equal to angle C. Opposite angles in the sense what, children? Okay, angle A is going to be equal to angle C, angle B is going to be equal to angle D. Clear? Angle A is equal to angle C, angle B is equal to angle D. And the very important property is diagonals bisect each other. Diagonals bisect each other. When I draw AC, okay, when I draw BD, they bisect each other. Bisecting in sense they divide each other into equal parts. Okay, so here I can say that AO is equal to OC and DO is equal to OB. Clear, children? So when one diagonal is drawn, keep in mind, children, only when one diagonal is drawn, it divides the parallelogram into two triangles which are congruent to each other. Which are congruent to each other. Whenever both the diagonals are drawn, okay, there are four triangles formed. All these four triangles are equal in area. Clear? Okay, these four triangles are equal in area. Clear, children? That is also one of the properties. Then fourth property is all the pair of adjacent angles are supplementary. All the pair of adjacent angles are supplementary. What do you mean by adjacent? So next to each other, in the sense of angle A plus angle B plus angle C, right, and angle C plus angle D plus angle A. When you find out all of them, they are equal to 180 degree. Okay, all the pair of adjacent angles are supplementary. These are the properties of parallelograms you need to understand, children. Clear? We are calling them as diagonal properties. So now let us study about the properties of a rectangle. Okay, what are the properties of a rectangle? As I told you, children, rectangle is a type of parallelogram. So obviously, what are the different properties of parallelogram we are discussed? All these properties are applicable for the rectangle also, because rectangle is a type of parallelogram. So I can say all the properties of parallelogram are holding good in the rectangle also. But other than these general properties of parallelogram, rectangle has the special properties also. What are the special properties? Each angle is 90 degree. Each angle is 90 degree. Okay, right. So whatever angles we have, right, the interior angles, each one of them is 90 degree. So I can better say each interior angle is 90 degree. So obviously each exterior angle is also 90 degree. And diagonals are equal to each other. Okay, equal to each other. Okay, right. So that happens in the case of a rectangle. Diagonals are equal to each other. Clear? So in the sense AC is equal to BD. This is the property of rectangle. So now we have the property of a square. Now let us see what are the properties of a square. Clear, children? Right. Square is written in this way. Listen to me very carefully. Square has maximum properties. Okay. As I told you, square is a type of parallelogram. I can say all the properties of parallelogram hold good in the case of square also. Other than these general properties, square has some of the special properties. What are they? All sides are equal to each other. All sides are equal to each other. Okay. So I can say that AB is equal to BC is equal to CD equal to DA. Clear? Then each angle is 90 degree. Each angle is 90 degree. So angle A is equal to angle B is equal to angle C is equal to angle D, that is equal to 90 degree. Then the next property is diagonals are equal to each other. Diagonals are equal to each other. Okay, see, we are learning the properties of square. Somebody is bursting the crackers over there. They also know, I think, that square has many properties. Okay, thank you, dear guys, for bursting the crackers. Right, so diagonals are equal to each other in the sense AC is equal to BD. Correct. So AC is equal to BD. Clear? Diagonals are perpendicular to each other. Diagonals are perpendicular to each other. Okay, actually they are perpendicular bisectors. Since we spoke about the properties of parallelogram, we said that diagonals bisect each other. So diagonals are perpendicular bisectors of each other. So I can say AC is perpendicular to BD. So the other property is diagonals bisect the vertex angle. Okay, diagonals bisect the vertex angle. So in the sense the each angle whatever is here, I know it is 90 degree. Since it is getting bisected means what? Each angle is 45, 45. This is also 45. This is also 45. This is 45, 45, 45. Everywhere it is 45 degree. Because diagonals bisect the vertex angle DBVA. Clear, children? And just like the properties of rectangle, we said that whenever one diagonal is drawn, okay, so one diagonal is drawn, look at this, it is again dividing the square into two congruent triangles. But when both the diagonals are drawn, the four triangles so formed are equal in area as well as they are congruent. They are equal in area as well as they are congruent. Keep in mind, children. So now next is properties of rhombus. Properties of rhombus. So square has the maximum property, children. Keep in mind. So the rhombus is again a type of parallelogram. See, those guys are not busting the crackers for rhombus. It's very unfair. Huh? They did only for square. Okay. Okay, we'll look into that later, right? So in the square, in the case of rhombus also, all sides are equal to each other. So since rhombus being the type of parallelogram, so I can say all properties of parallelogram it has. Other than the general properties of parallelogram, some of the special properties, some of the peculiar properties it has, that is all sides are equal to each other. All sides are equal to each other. In the sense, children, I can say if I naming it as A, B, C, D, AB is equal to BC is equal to CD equal to DA. Correct. So next one is what? Diagonals are perpendicular. Diagonals are perpendicular. Clear? So whenever diagonals are drawn, they are perpendicular to each other. If I am not saying they are equal to each other, they are not equal to each other. Whatever property is there, I am telling, children. Whatever is not there, I am not telling. Clear? So diagonals are not equal in the case of rhombus. Diagonals are equal only in the case of square and rectangle. But diagonals are perpendicular in the case of square as well as rhombus. But they are not perpendicular in the case of rectangle. So diagonals are perpendicular to each other. Diagonals are perpendicular to each other. And diagonals bisect the vertex angle. Diagonals bisect the vertex angle. Okay, so here you need to understand whatever is the angle that is getting bisected. Since we don't know what is this complete angle, we cannot say what is the value of each of these angles. Okay, whatever is the value of this angle, they both are equal to each other. That's all you can say. Just like the square, we cannot say it is 45. No. Okay, whatever is the value of this angle, the same value will be for this. Clear? So same thing will happen with this, and over here these two will be same. Clear, children? Diagonals bisect the vertex angle DBVA, I can say. Clear, children? Is that clear? Right. So whenever you are asked to prove that given quadrilateral is a square, rectangle or rhombus, first you need to prove it's a parallelogram. It's a parallelogram. Clear? So now we are going to deal conditions to prove a quadrilateral as a parallelogram. Okay, right. So to prove a quadrilateral as a parallelogram, how can I prove a quadrilateral as parallelogram? Prove any one of the following conditions. Prove any one of following conditions. What are the following conditions? Prove that both the pair of opposite sides are equal or parallel. Okay, so both the pair of opposite sides are equal or parallel. Either you should prove that this equal to this and this equal to this, or you should prove that whenever I'm talking about the parallelogram, you should prove that this is parallel to this as well as this is parallel to this. Okay, both the pair of opposite sides are equal and parallel. Second one, one pair of opposite sides are equal and parallel. Okay, need to understand the difference, children. Okay, here I need to prove one pair of opposite side equal as well as parallel. Clear? Then also we can say the quadrilateral is parallelogram. Or prove that both the pair of opposite angles are equal. Both the pair of opposite angles are equal. In the sense, if this is a quadrilateral, I need to prove that this angle is equal to this angle, or this angle is equal to this angle. Or prove that diagonals bisect each other. This is the most oftenly used condition to prove quadrilateral as a parallelogram. So I have a parallelogram over here. So I need to prove that diagonals AC and BD, they bisect each other. Then I can say ABCD is a parallelogram. Clear, children? And the fifth condition, all the pair of adjacent angles are supplementary. Okay, so all the properties of parallelogram you have to prove. So angle A plus angle B is equal to 180, or B plus C is equal to 180 degree, C plus D equal to 180 degree, D plus A equal to 180 degree. You are supposed to prove any one condition, not all the condition. Okay, so any one condition, okay, not all the condition. Okay, so any one condition out of this 5 condition you are proving, then we can say the quadrilateral is nothing but a parallelogram. Once you have proved it is a parallelogram, then how do you prove it's a square, rectangle or rhombus? Once you have proved it's a parallelogram, how do you prove it's a square, rectangle or rhombus? Clear, children? These are nothing but the properties what actually we have learned it. It is given in the form of table, which is given in your textbook also. Please go through this table. Once you understand this table, you can easily recall the properties. And again and again I'm telling you, if you know the properties, that is not at all sufficient. You must know how to apply, where to apply, when to apply these properties. Clear? So now we are going to learn how to prove a quadrilateral is a parallelogram. We learned it. Now we are going to prove how can we prove a parallelogram is a square, parallelogram is a rectangle, parallelogram is a rhombus. So first I will take how to prove a parallelogram is a rectangle. How to prove a parallelogram is a rectangle. Okay, so for that, children, I need to prove, please pay attention. First condition is what? A parallelogram is a rectangle. Just to prove that one angle is 90 degree. Enough. Okay, so if a parallelogram, one angle is 90 degree, that means what? It is getting shifted this side and it is becoming like this. it is a rectangle. Just this condition to be proved. In a parallelogram, just prove that one angle is 90 degree. That is understood that parallelogram is rectangle. So later, how can I prove the quadrilateral, that is parallelogram is a square? Parallelogram is a square. For that, prove that one angle, any one angle is 90 degree, and the second condition, adjacent at least one pair. Okay, so one pair of adjacent sides are equal. Okay, so now a parallelogram is there. I'm supposed to prove it's a square. So adjacent sides must be equal, this equal to this, and the angle should also be, this is adjacent to this is also adjacent to this, and angle should also be equal to 90 degree. So these are the two conditions to prove given parallelogram is a square. Then how can I prove that a parallelogram is a rhombus? How can I prove a parallelogram is a rhombus? Again, one condition over here, prove that one pair of adjacent sides are equal. Just prove that one pair of adjacent sides are equal. Clear? So this is a parallelogram. Just I am proving that the pair of adjacent sides are equal. This equal to this. So this 2 again becomes adjacent side. This 2 again becomes adjacent sides. See, square has two conditions to be proved. Rectangle again has one condition, and rhombus again has only one condition. Any one of these conditions for rectangle and rhombus, and both the condition for square. Okay, so keep in mind whenever you want to prove that given quadrilateral is a square, rectangle or rhombus, first you are supposed to prove it's a parallelogram. You cannot enter the class without entering the school. So first you need to go to school, in the sense you need to prove it's a parallelogram, then search for the class. Clear? Then you search for whether you belong to 9A, 9B, 9C. Means once you prove it's a parallelogram, then you search for whether it's a rectangle, square or rhombus. Clear, children? Right? So now we are going to solve the questions on the same, like properties of quadrilaterals. Let us start with the exercise. Yes, children, before we actually move on to the exercises, we are left with two more types of quadrilaterals to be discussed. Now let us study the properties of trapezium and kite, then we proceed with solving the exercises. Okay, now let me start with the other type of quadrilateral, that is trapezium. Okay, trapezium is a quadrilateral which has got only one pair of opposite sides parallel to each other. So if A, B, C, D is a trapezium, only one pair of opposite sides are parallel to each other. Only one pair of opposite sides are parallel. Okay, so these AD and BC are called as non-parallel sides. Okay, so if non-parallel sides are equal, then the trapezium is called as isosceles trapezium. Clear, children? Then it is called as isosceles trapezium. Look at this very carefully. Right, so this is a trapezium where the side A, B, C, D, I have named them. AB is parallel to CD, and AD is equal to BC. So then I can say the trapezium ABCD is isosceles trapezium. Clear? Right. So in the case of isosceles trapezium, these two are called as lower base angles, which are equal to each other, and these two are called as upper base angles, which are again equal to each other. As well as in the case of isosceles trapezium, that means what? AD is equal to BC. The diagonals are equal to each other. Okay, diagonals are equal to each other only in the case of isosceles trapezium. Keep in mind, children. Okay, this is the property of trapezium. Now, let me take the properties of kite. Okay, so what is a kite? All have seen a kite, how actually kite looks like. Okay, this is a kite which is a type of quadrilateral. So A, B, C, D. Correct. So I can draw the diagonals over here. Okay. So in the case of kite, the one pair of adjacent angles, upper adjacent angles over here, and this adjacent side, sorry, not angles, and this side are equal to each other. So DC is equal to BC, also AD is equal to AB, and diagonals are perpendicular to each other. But keep in mind, children, the longer diagonal bisect the shorter diagonal. Okay, they are not perpendicular bisectors of each other. Keep in mind. Okay, so the longer diagonal bisect the shorter diagonal. These are the properties of a kite. Clear? So now let us proceed with the exercise 14b. 14a was based on the properties of polygons. 14b is based upon properties of quadrilaterals as well as the properties of parallelograms and its types. In a quadrilateral, ABCD is a trapezium. See the first question where we are going to solve the multiple choice questions. Quadrilateral ABCD is a trapezium. Just now we dealt with the properties of a trapezium. Okay, so A, B, C, D is a trapezium. If AB is equal to DC, AB is equal to DC, AD is equal to BC, AD is equal to BC, okay, or A plus C is equal to 180, A plus C is equal to 180, B plus C equal to 180, B plus C equal to 180. So what is the right option? What do you think, children? Okay, so it is quadrilateral ABCD becomes a trapezium when it becomes a trapezium if A plus C is equal to 180 degree or B plus C is equal to 180 degree. B plus C is equal to 180 degree in the sense what? I can draw the trapezium like this as well. Okay, if I call this as A, B, C, D. Okay, so this angle and this angle are equal to each other, means what? They are supplement of each other. That means what? Co-interior angles are supplement of each other. That means here I can say AB is parallel to CD. So if these two angles are supplement of each other, AB is parallel to CD. So I can say this becomes a trapezium only on this condition. A plus C is equal to 180 degree, not necessary. Okay, it won't be. AD equal to BC, AD equal to BC, it can be, but that condition alone won't satisfy. Clear? If it is along with this, yes, fine, it is an isosceles trapezium. AB equal to DC, AB equal to DC, they are equal to each other, then I cannot say that the other two non-parallel sides are non-parallel in fact. Okay, right. So now let us see the next question. Which of the following is not true for a parallelogram? We studied about the properties of parallelogram. So we know that opposite sides are equal to the parallelogram. Yes, it holds good. Okay, opposite angles are equal. Yes, it holds good in the case of parallelogram. Opposite angles are bisected by the diagonals. No, it won't hold good. Diagonals bisect each other. Yes. Okay, the right answer is third one. Opposite angles are bisected by diagonals. No. Okay, so this is not the right answer, right property for the parallelogram. Clear, children? Yes. Now let us move to the next question. In the figure alongside, AM bisects angle A and DM bisects angle D, okay, of a parallelogram ABCD. Prove that angle AMD is equal to 90 degree. Okay, so whenever it is a proof type of question, children, okay, always you need to have the habit of writing what is given. What is given? First of all, ABCD is a parallelogram. It is given to you. The second one is what? AM and DM bisect angle A and angle D respectively. Right. So what to be proved? To prove what we are supposed to prove? We are supposed to prove that AMD is equal to 90 degree. So now let us start proof. We know that in parallelogram ABCD, angle A plus angle D is equal to 180 degree because adjacent angles are supplementary. Okay, so what I do? Angle A by 2 plus angle D by 2 is equal to 180 by 2. What did I do? Here I have divided by 2 on both the side. On both side. Half of angle A, I can either take this angle or this angle. So I will take it as a DAM. Half of angle A is a DAM plus of half of angle D is a ADM. ADM is equal to 90 by 2 is, 180 by 2 is 90. I call this as equation 1. So in triangle DMA, I'll apply angle sum property. Angle DAM plus of ADM plus of AMD is equal to 180 degree. That is angle sum property of triangle. So these together, I know it is 90 degree plus of angle AMD is equal to 180 degree. This is from 1 because in equation 1 I have proved that sum of these two angle equal to 90 degree. So now I can say that AMD is equal to 180 degree minus of 90 degree, that is AMD is equal to 90 degree. Hence proved. Clear, children? You are asked to prove AMD. I have proved it. See, you are supposed to give the reason. You should not forget to give the reason for your steps. Why have you written this as 90 degree? It is from equation 1. Here in the equation 1, it is equal to 90 degree. Here you need to equate it equation 1, then from 1 you have to write. So means what? Your answer should be convincing to the evaluator, not confusing. Clear, children? Now let us move to the next one. The given figure shows a square, right? So what is given over here? A, B, C, D is a square. It is given to you. That is one thing what is given. And other part is ABP is equilateral. Triangle ABP is equilateral. It is equilateral. So you are supposed to calculate AOB, BPC and PCD also reflex of APC. So let us see how can we prove it. So now let me mark it, children, over here. See, this is ABP is equilateral in the sense you know that equilateral triangle, each angle is 60 degree. This is 60 degree. Also this is 60 degree. And in a square, each angle is 90 degree. This is 60 degree, means this is 30 degree. Also this is 30 degree. Clear, children? Okay. So now you are asked to find out AOB, means what? This angle is how much? Is the question. Clear? So now let me take that one first. What can I write over here? AOB, yes, AOB. This angle is how much? As triangle ABP is equilateral. As triangle ABP is equilateral, I can say angle AB is equal to angle ABP is equal to angle APB is equal to 60 degree. Clear? Also since diagonals bisect the vertex angle, diagonals bisect the vertex angle in square, so I can say that angle DBA, which is same as OBA, is equal to 45 degree. Clear? So next what I do, I will apply angle sum property in triangle OBA. In triangle OBA, angle OBA plus of AOB plus of OAB is equal to 180 degree. This is angle sum property of triangle. OBA is how much? Here we have found it out, that is 45 degree. Clear? AOB is the angle which I am supposed to find out, plus OAB is nothing but 60 degree is equal to 180 degree. So now AOB is equal to 60 plus 45 is 105, 180 minus 105 is 75. So I have found out AOB is equal to 75 degree. Now let us find out the second angle BPC. So BPC. Now I am supposed to find out that one. So here, as triangle ABP is equilateral, I can say that AB is equal to PB. Again, as ABCD is a square, since it is a square, I can say that AB is also equal to BC. So I just call this as 1 and 2. So equals to equal are equal to each other from 1 and 2. See, AB is equal to PB, AB is equal to BC. So I can say that PB is equal to BC. PB is equal to BC. Observe this triangle, children. Observe this triangle. Okay. PB is equal to BC. In the sense, can I say triangle BPC is isosceles. So that means what? Angle BPC is equal to BCP is equal to each other, and they are equal to 180 degree minus of PBC divided by 2. So that is 180 degree minus of 30 degree divided by 2. So what does it mean? That means BPC is equal to BCP is equal to 75. Clear, children? So you are going to get this angles also as 75. So now you are supposed to find out PCD is how much? PCD is, once you have got this as 75 degree, PCD is nothing but 90 degree minus PCB. Clear, children? So now I can say that angle PCD is equal to angle PCD is equal to BCD minus PCB. Okay, angle BCD minus of PCB. So that is 90 degree minus of 75 degree, that is equal to 15. So PCD is equal to 15 I got. Next question is reflex APC. So APC is how much? APC is equal to 60 plus 75. Okay, so this is our third question. Now fourth question is angle APC is equal to 60 plus 75, that is 135 degree. So if I am finding out a reflex of angle APC, that is 360 degree minus of 135 degree. Okay, whenever the angle is over here, children, the other side of the angle is called as a reflex angle, for your kind information. So means what? In this case, this angle is called as a reflex angle, okay, which is nothing but 360 degree minus of this angle. So here we get it as 225 degree, that is reflex of APC. Clear, children? So now let us move to the next question. In each of the following figure, ABCD is a parallelogram. So you need to find out the value of X and Y. Okay. So I can say, since ABCD is a parallelogram, so AB is equal to DC. So means 4x is equal to 6y plus 2. Clear, children? Okay. So now I can take out 2 common over here. So I can write this one as 2x, then again 2 can be taken common, 3x plus 1. So this 2 will get cancelled. I can write 3x, okay, this is 3y, 3x is equal to, 2x is equal to 3y plus 1. So 2x minus 3y is equal to 1. This is first equation. Clear? So next, what can I write? I can say y. This is opposite sides of parallelogram which are equal to each other. Right. So similarly, I can write AD is equal to BC. They are again opposite sides. So AD is how much? AD is 4y is equal to BC. BC is how much? 3x minus 3. So I can write 3x minus 4y is equal to 3. This is our second equation. You know how to solve a simultaneous equation by elimination method, children. So what I do, equation 1 multiplied by 3 minus of equation 2 multiplied by 2 I do. Equation 1 multiplied by 3 if I do, then I would get this as 6x minus 9y is equal to 3. Equation 2 multiplied by 2 if I do, 6x minus of 8y is equal to 6. So I have to subtract them. So change the sign. These two will get cancelled. Minus y is equal to minus 3. Y is equal to 3 I will get. Now what I am supposed to do? Substitute y in any one of the equation. Equation 1 I do. So 2x minus 3 into 3 is equal to 1. 2x minus 9 is equal to 1. So 2x is equal to 1 plus 9. 2x is equal to 10. X is equal to 5. So I'm finding out x by substituting y in equation 1. So x is equal to 5 and y is equal to 3. If you want to find out the sides, AD is equal to 4y. 4 into 3, that is 12 units. So AD will be same as BC is equal to 12 units. So similarly, how much will be AB? AB is equal to 4x. 4 into 5, that is 20 units. So AB is same as DC equal to 20 units. Clear, children? Is that clear? Okay. Now let us proceed with the next question. A parallelogram ABCD. AB is equal to 20 centimeter. Okay. There is a parallelogram ABCD. Look at this. ABCD is a parallelogram. Okay. A, B, C and D is a parallelogram. AD is equal to 12 centimeter. This is 12 centimeter. The bisector of angle A meets DC at E. Okay. Bisector of angle A means what? It is bisecting this angle. Okay. It is meeting DC at point E and BC produced at F. I will extend this BC. It is going to meet this BC produced at F. Find the length of CF. How much is this? Is the question. Clear, children? So now you know that since ABCD is a parallelogram, I can say that AD is equal to BC is equal to 12 centimeter. So this is also going to be 12 centimeter. Clear, children? So as DC is parallel to AB, so I can say angle EAB is equal to AED. Clear, children? So this angle is equal to this angle. Why? So interior alternate angles. Clear? So that implies in triangle ADE, in triangle ADE, AD is equal to DE. Tell me why? Because sides opposite to equal angles. Sides opposite to equal angles. So this also becomes 12 centimeter. Clear, children? Okay. So now this is 12 centimeter. This is 12 centimeter. I know. Okay. So they have given you AB is equal to 20 centimeter. So this total is 20 centimeter. So now can you tell me how much is EC now? Right. So AB is equal to CD is equal to 20 centimeter. Again, they are opposite sides of the parallelogram. Okay, so CD is equal to 20 centimeter. DE plus of EC is equal to 20 centimeter. DE I got to know 12. EC I'm supposed to find it out. So EC is equal to 20 minus 12. EC is equal to 8 centimeter. So I get this one as a 8 centimeter. Clear, children? Okay. So now pay attention, children. So this angle is equal to this angle. Alright. So this angle is equal to this angle. Interior alternate angles. Clear? Okay. So next, listen to me very carefully. Angle DEA is equal to angle CEF. CEF. Why? Vertically opposite angles. Also, angle EAD is equal to this angle is equal to this angle EFC. EFC, interior alternate angles. Clear? So as angle DEA is equal to EAD. Okay, EAD. This is already proved. That implies, so since these two are equal to each other, these two will be equal to each other. CEF will be equal to EFC. Okay, so these two angles become equal to each other. So that implies triangle ECF is isosceles. Why? Because I can say EC is equal to CF. They are nothing but sides opposite to equal angles. Sides opposite to equal angles. So I can say CF is equal to EC, but we have already got what is the length of EC. So CF is equal to 8 centimeter. Clear, children? Is it clear? Yes? Okay. Now let us move to the next question. Yes, children. Now it is not a next question. It is a next exercise. Again, this exercise is completely based upon the properties of all the types of quadrilaterals and the parallelograms what actually we studied. Clear? So let us solve some of the questions of exercise 14C. First, let me take the multiple choice questions. See, in the question, it says that BEC is an equilateral triangle inside the square ABCD. So you have a square like this. This is a square ABCD. Pay attention, children. So ABCD is a square. The value of angle ECD is, okay, BEC is a equilateral triangle. So this angle side equal to this side equal to this side. So if it is equilateral triangle, then the value of each angle should be 60 degree. Okay, the value of each interior angle of a equilateral triangle is 60 degree. Now you're asked to find out the angle ECD is how much. ECD, this is how much. How much is this question? This angle is the question. Clear, children? You know that this complete angle is 90 degree. Why tell me? Because it's a square. Out of that, this alone is 60 degree. So this is supposed to be how much, children? It is supposed to be 90 minus 60, that is equal to 30 degree. So 30 degree is the right answer. Clear, children? Now let me take the next question. So here the alongside figure shows a parallelogram ABCD in which AE is equal to EF equal to FC. So now what is given over here? You must know that ABCD is a parallelogram that is given to you, and AE is equal to EF is equal to FE is given to you. You are supposed to prove that DE is parallel to FB. DE is parallel to FB. You are supposed to prove. Clear, children? So now proof. Look at the screen very carefully. So first one, I'll take the triangle. I'll take the triangle ADE and triangle CBF. Okay. So here I can say that AD is equal to CB. They are nothing but opposite sides of parallelogram. Then I can say that AE is equal to CF, that is your data, and the angle DAE is equal to angle BCF. Now pay attention, children. DAE is this angle, BCF is this angle. Can you tell me why they are equal to each other? Yes, you are right. They are interior alternate angles. Interior alternate angles. So therefore I can say triangle ADE is congruent to triangle CBF by side angle side congruency. So that implies angle AED is equal to CFB. So that is by CPCTE. Clear, children? So means what? AED in the sense that this angle is equal to CFB in the sense this angle. Clear? So now what I do like 180 minus AED will be equal to 180 minus of CFB. So they form a linear pair. Equal subtracted from equals, reminders are equal. 180 minus AED if I do, I will get this angle, children. Clear? So I'll get it as DEF is equal to, then again I'll get over here BFE, that is BFE. Alright, so since angle DEF and BFE are interior alternate angles, okay, you need to understand, children, they are nothing but the interior alternate angles when the transversal EF is a transversal drawn to a pair of parallel lines. FB is parallel to DE. So this acts like a interior alternate, transversal. Therefore, this angle is equal to this angle. So since the interior alternate angles are equal, right, so we can say, what can we conclude? Say that DEF is equal to BFE are interior alternate angles and they are equal, so that implies DE is parallel to BF. Okay, so DE is parallel to BF we have proved. Now we have to prove that DE is equal to FB. So here itself we can say this is our first proof. Okay, so now second proof, as triangle ADE is congruent to CBF, proved, we have already proved it in first part, that implies DE is equal to FB. This is by CPCTE. Clear? So we got to know this also. Now you have to prove that DEBF is a parallelogram. DEBF. Now I will join this. I will join this. So now pay attention, children, for the third one, in quadrilateral, because I don't know still it's a parallelogram or not. Okay, so in quadrilateral DEBF, we got to know that DE is equal to BF and DE is parallel to BF. So that means I can say DEBF is a quadrilateral in which one pair of opposite sides are equal and parallel. So that implies DEBF is a parallelogram. All that things we have discussed it earlier, children. Okay, how to prove a quadrilateral is a parallelogram and all, we have already discussed it. Okay, so now let's move to the next one. Right, so here in the given figure ABCD is a parallelogram. So given that ABCD is a parallelogram, okay, it is given to you that it is a parallelogram. We need to prove what we are supposed to prove. We are supposed to prove that AB is equal to twice of BC. Clear? Right, so proof, let us see how to prove it. Right, so now please pay attention. Here they have given that this equal to this, AE bisects angle A, BE bisects angle B. So now I can say that angle DAE is equal to EAB. This is given, right? But I can say that EAB is equal to AED. So that is interior alternate angles. So equals to equals are equal. So I can say that DAE is equal to AED. So DAE is equal to AED. This angle also equal. So that implies in triangle ADE, AD is equal to DE. They are nothing but the sides opposite to equal angles. You should give the reason, children. Sides opposite to equal angles. Okay, I'll just call this as equation 1. So similarly, I can write that angle CBE is equal to EBA. This is given to you, but I can say that EBA is equal to BEC, interior alternate angles. So that implies that CBE is equal to BEC. CBE equal to BEC. Again, these two angles are equal to each other. So that implies in triangle BEC, BC is equal to EC. Why? They are nothing but sides opposite to equal angles. They are the sides opposite to equal angles. Clear, children? I'll just call this as equation 2. Now what I'm supposed to prove, AB is equal to twice of BC we are supposed to write. Okay, so next what I do is AB is equal to, look at this, DC, correct, children? AB is equal to DC. Why, tell me? Because they are opposite sides of a parallelogram. Okay, so I can write AB is equal to DC, and DC can be written as what? DE plus EC. Clear? DE plus EC. Now can I write DE is same as AD? Okay, EC is same as BC, that is from 1 and 2. Okay, so from 1 and 2 I can say that uh, AD is equal to BC. Clear? So now AD will be same as BC. Can you tell me why? Because they are opposite sides of the parallelogram. So in place of AD, I will write it as BC plus BC. So opposite sides of a parallelogram. Clear, children? So AB equal to DC, I can directly write AB over here. So AB is equal to twice of BC. So hence proved. Clear? Logically, you try connecting one in terms of the other, you will definitely get the answer. Now let us solve the next one. In the following figure, ABCD is a parallelogram. So it is given you that ABCD is a parallelogram. We need to prove AP bisects angle A. This is the other way around. Clear? So just complete reverse case of the previous one. Right. So proof, pay attention. So here look at the figure very carefully. Right. So now in triangle ADP, AD is equal to DP. This is given to you. Clear? So that implies angle DAP is equal to DPA. They are nothing but base angles of a isosceles triangle. Clear, children? Okay, but can I say angle DPA is equal to, means this angle is equal to this angle? Tell me why. Interior alternate angles, PAB, that is interior alternate angles. Okay, see, look at this. DPA is equal to DAP also, DPA is equal to PAB also. Equals to equal are equal. DAP is equal to PAB. So DAP is equal to PAB. So that means what? That means what? AP bisects angle A. We proved the first one. So similarly, BP bisects angle B. We are supposed to prove in the same way, children. Okay. So now what can I say? AD is equal to BC. They are opposite sides of the parallelogram. Correct, children? Okay. AD is equal to BC, but AD is equal to DP is equal to PC. This is given to you. So can I say that PC is equal to BC? See, BC is equal to AD also. Okay, but AD is equal to PC. So AD is equal to BC also, AD is equal to PC also. We can say PC equal to BC. Clear, children? Okay, I'll just call this as equation 1. PC equal to BC we have proved. Now we have to prove that BP bisects angle B. So that implies in triangle BPC angle CPB is equal to CBP. Okay, they are nothing but the base angles. You must know, children, base angles often I am using. I told you to watch the isosceles triangle and the congruency of triangle video also to understand these okay definitions in a better way. Okay, this equal to this, that means they are isosceles triangle. These are the base angles what we call, and they will also be equal to each other always in case of isosceles triangle. Keep in mind. Clear? So now we prove that CPB equal to CBP, but we can say CPB is equal to this angle is equal to this angle, that is PBA, interior alternate angles. Okay, so listen, CPB this angle is equal to this angle, and CPB this angle is also equal to this angle. Clear? So that implies angle CBP. Okay, CBP is equal to CPB, but CPB is equal to PBA, right? PBA. So I can say that this angle is equal to this angle, that is CBP is equal to PBA. So that implies PB bisects angle, PB bisects angle B. Clear? Clear? Right. So now we have to prove that DAP plus CBP equal to APB. So now look at this. DAP in the sense, what is DAP? DAP, this angle, plus CBP is this angle, is equal to APB. We are supposed to prove it is equal to this one. Clear? Now pay attention. We are going to prove the third one. Okay, so look at the board now. So DAP plus CBP is equal to DAP plus CBP. Look at the screen very carefully. DAP can be written as, look at this, DAP can be written as PAB, correct? PAB, that is interior alternate angles. Clear? Plus of CBP can also be written as a PBA, right? So PAB is same as DAP. So we know that AP bisects angle A. CBP is same as CBA. Clear? Right. So now pay attention, children. This is equal to APB we are supposed to prove. Alright. So now why this is equal to, look at the screen very carefully. PAB plus CBA means what? PAB is this angle. CBA, PBA, not CBA, PBA is this angle. Clear? Okay, is equal to, what can I say? This equal to 180 degree minus of APB. Okay, that is in case of triangle APB. In case of triangle APB. Clear? So I just call this as equation 2. So next what I do is, look at this angle A, that is DAB, plus of angle CBA is equals to 180 degree. That is nothing but adjacent angles of a parallelogram. So if I divide both the side by 2, so DAB, half of DAB is PAB, correct? PAB plus of half of CBA is, how much is half of CBA? Half of CBA is nothing but PBA. That is equal to 90 degree. Clear? So PAB plus PBA is equal to 90 degree I get. Clear? So that implies from 2 we can say that this is our equation. This is equal to 90 degree I got. Okay, so APB, if I substitute this as 90 degree, look at this, in place of this, okay, which one? In place of this PAB plus PBA, I will write it as 90 degree in equation 2. Clear? So now I'll write it as 90 equal to 180 minus of APB. Right. So I can write angle APB is equal to, I will take this one over here and this one over here. So that is 180 minus 90, that is equal to 90. Clear? I got what I got, children. I got APB is also equal to 90 degree. Okay. So angle APB is equal to 90 degree. And I got PAB plus PBA is also equal to 90 degree, and PAB plus PBA is also equal to 90 degree. So what does it indicate, children? That indicates PAB plus of PBA is equal to APB. Okay, PAB plus, okay, BPA is equal to I get it as APB, but I'm supposed to get DAP. So can I say PAB? PAB, PAB is same as DAP. So I'll replace PAB as DAP plus of PBA. PBA. Clear? It is same as CBP. Correct, children? So I'll replace it as CBP is equal to angle APB. Hence, this is not only one way, children. You can prove it in many ways. This is one of the way. Clear? Is that clear? Yes. Now let us move to the next problem. ABCD is a square. Okay. So ABCD is a square. This is a square. It is given to you. ABCD is a square. Right. A is joined to a point P on BC. There is a point B, P on BC over here. BC is here. A is joined to this. A is connected to this. And D is joined to a point Q on AB. Okay. This is point Q. Then what is connected? D is connected. This is connected like this. Clear? If AP is equal to DQ, so that is given to you. AP is equal to DQ. Clear? That is given to you. Okay. So what are AP is this side. This is equal to DQ is given to. These two are equal to each other. It is given to. Prove that AP and DQ are perpendicular to each other. You are supposed to prove that they meet each other at 90 degree. Clear, children? Yes or no? Okay. So now what I do? Listen to me very carefully. I will take the triangle ABP and triangle DABP. DAQ. DAQ. Alright. So AB is equal to DA, sides of square. Then I can say that AP is equal to DQ. It is given to you in the question. Then I can say that angle ABP is equal to DAQ. Both of them are 90 degree. Clear? So now it is 90 degree over here. So using the RHS congruency, so I can say the triangle ABP is congruent to triangle DAQ by RHS congruency. Right? So I can say that angle, look at this angle APB is equal to angle APB is equal to angle DQA. Okay, angle DQA. So this angle is equal to this angle. Clear? Okay. So by CPCTE. Right, children? Okay. So that means what? This angle over here is equal to this angle. These two angles are also equal to each other by CPCTE. Clear? So now I can say that this angle is X. This angle is also X. I hope so you are getting it what I mean to say, children. Okay. So both the angles are being X over there. Clear? So here I will just show it to you in a better way. So this angle over here, see, this is X I am mentioning. This also becomes X, and this angle, if I take it as Y, this also becomes Y. Clear? This also becomes Y. Getting it? Very important, children. Okay. So they both of them are equal to each other. So now what I'm going to do is, look at this very carefully. I will take this angle as Y and this angle also as Y. So if I call this point as P, in triangle AQP, X plus Y plus of angle plus of angle APQ is equal to 180 degree. Clear? Okay, plus of angle APQ is equal to 180 degree. Now pay attention, children. So I have this x plus y over here, x plus y. So x is this angle over here, and this angle is also x, and this angle is y, this angle is also y. So can we say that they are perpendicular to each other? We are supposed to prove. So now listen, what I do here is I will just write this angle. Can I say this angle also is x? Can you tell me why, children? Because interior alternate angles. This angle is also x because interior alternate angles. Clear? So in this one, what is the value of this angle? Y we have taken. We have taken it as y. Alright. So look at this. I'll just call this as equation 1. Now angle APB is equal to PAD is equal to x degree, interior alternate angles. Okay, this also has x. That implies angle QAP plus PAD is equal to angle BAD. QAP is how much? QAP is y we have taken. PAD is y, x we have taken. BAD is how much? Angle of a square, that is equal to 90 degree. Okay, x plus y is equal to 90 degree. I call it as 2. So from 1 and 2. From 1 and 2, in place of x plus y, I'll replace it as 90. 90 plus of APQ is equal to 180. So that implies APQ is equal to 180 minus 90. APQ is equal to 90 degree. Clear? So that implies AP is perpendicular to APQ is 90 degree means what? AP is perpendicular to QD. Clear, children? All of you? Yes? Okay. Yes. So now, children, this is the end of the session. So I hope so you enjoyed the session. All right. So please subscribe the channel. It is a kind of motivation to me. Rest of the questions from test yourself, it is just a continuation of whatever we have done in these 3 exercises. So that should be solved by you, and you please take it as homework. Please don't forget to subscribe the channel, children, and share the same video with your friends and ask them to subscribe. Clear? So let us see you all guys with one more video. Till then, take care, keep working. Bye bye.